Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for our upcoming test. So we're going to start with directed numbers. They're so called because this sign here, the negative sign in front of a number, is just a direction sign. So minus 21 or negative 21 means that the number is 21 below 0. This sign here just means it's below rather than above 0, whereas positive numbers are above 0. So we're going to look at the four operations, starting with adding and subtracting. So the rule you need to know here is when you add a positive, then you're going right on the number line and making the number larger. When you subtract a positive number, you go left on the number line, you're making the number smaller. Now, these two facts probably seem really commonsensical. They're completely trivial. Surely everyone knows that. But people always make mistakes by not following these rules when they are doing calculations involving directed numbers. So we have a few examples here. So let's start with this one, minus 21 plus 18. So yeah, it's obvious. If you're adding 18, you're going to make the number bigger. The answer should be bigger than what you started with at minus 21. But a lot of people don't think about that. A lot of people tell you the answer here is minus 39, but that doesn't work because minus 39 is actually less than minus 21. Even though 39 is clearly bigger than 21, when you stick a minus sign in front, you change this inequality here. So remember, when you're doing these inequalities less than or greater than, the crocodile eats the bigger number. So the bigger number here is minus 21, so that's why this symbol here is pointing to the left. So the crocodile's mouth eats minus 21. So the answer can't be minus 39 because when you add 18, when you add a positive, you're making the number larger. So then what is the answer? Well, hopefully you can see the answer here is just minus 3. See, that sort of makes sense because minus 3 is actually greater than minus 21. Once again, I knew which way the inequality goes because crocodile eats the larger number. Now, when I'm talking about right and left, I'm talking about a number line. If you didn't know what minus 21 plus 18 was, what you could do is draw a rough number line. So for minus 21, we start here. Because we're adding a positive, we're going to the right. So I can go 18 spots to the right. So if I were to count out, 1, 2, 3, 4, 5, 18 spots to the right, it would take a long time. It's probably not viable in the test. But what we can do is skip count. So we could go 8 to the right. So if I go 8 to the right, I end up at minus 13. Because as I go to the right, numbers are getting larger. In fact, that's why the greater than symbol points to the right. Because as we go to the right on the number line, numbers are getting larger. So after I've gone 8 to the right, I need to go another 10 to the right. So minus 13 and 10 to the right. Well, it wouldn't be minus 23 because minus 23 would be over here. It is to the left. But if I go to the right, it would end up at minus 3. And that's our final answer. You don't need to draw the number line, but it just might help if you're really stuck. So let's do this one here. Minus 4 subtract 14. So this time we are subtracting a positive. So we're going left on the number line. Our answer should be smaller. Our answer is going to be smaller than the minus 4 that we started with. So even if you don't want to represent the whole journey on the number line like I did here, what you can do is just draw a number line. We'll start at minus 4. Just know that 0 is over here and we're going to the left. So the number is going to be further away from 0. So if I end up going 14 to the left, I end up over here at minus 18 because the difference between these two numbers is 14. So I've gone 14 to the left. I went to the left because I'm subtracting a positive. So minus 4 minus 14 actually gives minus 18. So let's look at this example here. So we've got 5 plus negative 12. Well, how are we going to do that? Because we only know how to add a positive or subtract a positive. Well, what we're going to do is we're going to use these rules here. So when you're adding and subtracting directed numbers, if you have a positive sign next to a minus sign, then you can just combine that into one minus sign. So I can just turn this into 5 minus 12. Again, if you want to use a number line, that's fine, but the answer I get is minus 7. So because I ended up subtracting a positive, I ended up with a lower number than I started with. So similarly here, we're subtracting a negative. So we're going to use this rule here. If you have two negatives next to each other, then they equal a positive. So I can turn these two negatives, two minuses, into a positive. So this is minus 320 plus 104. So this would be hard to draw on a number line because, heaps of numbers between them. But what we need to know is that we're starting at minus 20, we're going 104, we're going closer to 0. So we're starting like way over here, minus 320, and we're going closer to 0. So the answer should still be negative, but closer to 0 than this number. So the answer is minus 216. So make sure you understand for these rules, plus and a minus equals a minus, and two negatives equal a positive. That only works when these two signs are right next to each other. For example, here we had a negative subtract another number. We can't turn these two into a plus because they're not right next to each other. All right, let's move on now to multiplying and dividing. So multiplying and dividing mixed numbers is generally easier. The reason is you can just multiply or divide the numbers as normal, which you know how to do, and then you decide is your answer positive or negative. Now, these rules look similar to the ones on the previous slide, but they're a bit different. See, now when we're talking about multiplying or dividing, when I say a minus and a positive is a negative, we're talking about the answer. This means if you multiply or divide a negative and a positive, it doesn't matter in which order, the answer is negative. And I'm saying if you multiply or divide two negatives, the answer is positive. So make sure you understand the difference between these rules, multiplying and dividing, and the rules when we're adding or subtracting. So to do this calculation here, what I do is I ignore the minus sign to begin with. I'm just going to do 36 times 6. Now, if you don't know what that is off the top of your head, because you won't have calculated in the test, you can just do like long multiplication, 36 times 6. So 6 times 6 is 36. Then now we've got to do 6 times 30, so we put a 0. 6 times 3 is 18. 36 plus 180 is 216. So 36 times 6 is 216. Now I decide, is my answer positive or negative? Well, I'm multiplying a negative by a positive. So that means my final answer should be negative. So in this one here, minus 81 divided by negative 9. So I just go 81 divided by 9. Hopefully you know that that is 9. Now, I say, is my answer positive or negative? Well, I'm dividing a negative by a negative, so my answer is positive. I just leave this as positive 9. So you'll also need to be able to do questions like this where you have to find a number that goes in the box. So, minus 7 times what equals 56? Well, what we can do is just the opposite of the operation between the number and the box. So, the way we undo timesing is dividing. So, what would go in the box is just 56 divided by negative 7. So, here we have a positive number divided by a negative. So that's this rule here. It doesn't matter the order. It doesn't matter whether the positive number is first or the negative number is first, as up here. When you have one positive, one negative, and you either multiply or divide, your answer's negative. So 56 divided 7 is 8, and the answer is negative. Let's now look at order of operations. So the acronym for order of operations is BIDMAS. So you do anything in the brackets first, then index means power, so powers come next. Now division and multiplication, they're sort of the same rank. So what that means is you don't always do division before multiplication. Because they're the same, you do whichever comes first, left to right. So if the multiplication comes first, you do that first. If the division comes first, you do that first. And similarly, addition and subtraction, they're the same rank. So whichever comes first, left to right, that's the one you do first. But you always do multiplication and division before addition and subtraction, unless it's in brackets. So let's look at some examples. 12 minus 5 times 3. So a lot of people would be tempted to do the subtraction first, but our order of operations says multiplication is before subtraction. So the way we do this, and showing my working, I'd go 12 minus 5 times 3 is 15. So all I did to get from here to here is do this first. 5 times 3 is 15. And 12 minus 15, now that we know directed numbers, we know is minus 3. So let's do this one here. So here we have brackets. We need to do everything in the brackets first. So what's in the brackets? Well, we are adding, multiplying, and dividing. BidMaths tells us that multiplication and division is first, then we're going to do the adding. So because multiplication is first from left to right, I'm going to do that first. So this is my next line of working. So I'm going to leave the 7 alone. 4 times 8 is 32. And I'm going to leave the division alone. I'll do that in a sec. Divide by minus 2, and then we'll square it. Now, 32 divided by negative 2 is negative 16. So I've got 7 plus negative 16. And then I'm going to square it. I did the division first because division comes before addition. So remember what we said in the previous slide. So 7 plus negative 16. If the plus and the minus are next to each other, you can just change that to a minus. This is 7 subtract 16 and then square your answer. We do subtraction before we do the squared. Normally we do indices before subtraction, but subtraction is actually in the brackets. That's why I'm going to do subtraction first, because it's in the brackets. So 7 minus 16 gives it minus 9, and then I'm going to square that. So next line of working, I have minus 9 squared. Now, whenever you square a negative, your answer is always positive. Negative 9 squared is positive 81 because it's minus 9 times minus 9. That's what squared means. It means times it by itself. So you're timesing a negative by a negative. That's why the answer is positive. All right, let's look at this one here. Now, it probably looks a bit scary, but don't stress. Just do this methodically. Go through what is the first operation. So here we have 2 sets of brackets. So what we're going to do is we're going to do the inner brackets first. We're going to do all of this first. So the operations we have, we're subtracting, we're adding, we're multiplying. Multiplication gets done first. So my next line of working, I'm going to leave the minus 18 by itself, divided by. So I have minus 4, negative 3 times negative 2 actually gives me positive 6. So it's minus 4 plus 6 plus 7. Now, because I have 2 minuses next to each other, remember, I can make that a positive. So it becomes plus 7 plus 3, and then I'm going to square all that. So now I'm going to do all of these additions in the inner bracket. So minus 4 plus 6 is 2, plus 7 is 9, plus 3 is 12. So my next line of working out is minus 18 divided by 12 squared. So minus 18 divided by 12 is minus 1.5. So I get minus 1.5 squared. So remember, whenever we square a negative, the answer is going to be positive because it's a negative times itself, a negative times a negative. So 1.5 squared is 2.25. If you can't do it in your head, use long multiplication. So final answer there is minus 2.25. Now, sometimes in order of operations questions, you'll be given an expression in which you have to insert brackets. So let's look at this one here. Minus 8 minus 3 times 2 equals minus 22. That is a false statement. We're supposed to do this first. Minus 8 subtract 6 doesn't equal minus 22. But what we can do is insert brackets here to make it a true statement. Now, please understand that all brackets do is change the order of operations. There's only 2 operations here, minus and a times. So if I want to change the order of operations, I want to do the minus first, all I do is put brackets around it. So if I put the brackets here, now I've changed the order of operations. So I go -8 minus 3, which is -11, times 2 is -22. So I'm done. Now it's a true statement. So in this statement here, it's also not true. -4 times 5 minus 1 divided by 3, that doesn't equal -7. It equals some weird number because you get a fraction here. So I need to change the order of operations. What I would normally do is multiplication, then division, and then I'd subtract the two answers. I'd do the subtraction last. So I need to put brackets in a place where it can change the order of operations. So for example, if I put the brackets here, then it changes the order of operations because I do multiplication, then subtraction, and then divide my answer. So if I put it here, I get -20 minus 1, which is -21, divided by 3 is -7. This is now a true statement, so I'm done. All right, let's now move on to fractions. So you probably know what fractions are. So let's look at these two circles here and divide them up. So I've divided this first circle into quarters. Each of these is 1/4 of the whole circle. So basically the bottom number of the fraction, which is called the denominator, tells you how many parts you've divided it into, and the top number, the numerator, tells you how many parts you have. So here I've divided the circle into 4 parts, and this is one of those parts. So that's what it means. Now, if you get like a pizza, they don't cut it into quarters, they cut it into eighths like this. So each of these little slices is 1/8 because I've divided the circle into 8 equal parts, or they're supposed to be equal, and I have one of them. Each of these is one of those eighths. So these two circles are exactly the same size, and this section here is the same as this section here. So if I cut a pizza into quarters and I gave you one of those quarters, you'd get the same amount of pizza as if I cut it into eighths and I gave you 2 of these eighths. So these two sections in yellow are equal. They're the same amount. 1/4 is the same as 2/8. We call those equivalent fractions. These two here have the same value. They're both equal to 0.25. If you got 1/4 of the pizza, you get exactly the same amount as if you got 2/8 of the pizza. These are equivalent. They're the same value, but they're just written a different way. And we can also see that on the number line. So here I have a number line between 0 and 1. So if I have 5 divisions here, I'm actually dividing it into sixths. So this would be 1/6, 2/6, and so on. Now, if I have 2 divisions between 0 and 1, I'm actually dividing it into thirds. So this would be 1/3 and 2/3. So what we can see here is that 2/6 and 1/3, they are equivalent fractions. If I give you 1/3 of my chocolates, you will get exactly the same number as if I give you 2/6. Equivalent fractions occupy the same place on the number line. Similarly, 2/3 and 4/6 are equivalent fractions. They both have the same value and occupy the same value on the number line. Now, if I wanted to divide it with 1, 2, 3, 4 divisions, I'm dividing the number line into fifths. And here where I had 9 division, I divide it into tenths. So again, 1/5, 2/10 are the same fraction. These two, 2/5 equals 4/10, 3/5 equals 6/10, 4/5 equals 8/10. These pairs are equivalent fraction. 3/5 and 6/10 occupy the same position on the number line. They're both a little bit more than a half, which is here, and they have exactly the same value. So how can we tell easily if 2 fractions are equivalent? Well, it's actually pretty simple. 2 fractions will be equivalent if what you do to the top is what you do to the bottom. What do I mean by that? Well, to go from 1 to 2, I've times the top by 2. I multiplied the numerator by 2 here. So if I multiply the denominator by the same number, also multiply it by 2, which I've done, then the fractions will be equivalent. But if I have fractions like 2 over 5 and 9 over 10, they're not equivalent. See, what I've done here is I've times the bottom by 2, but I've times the top by 4.5. I haven't done the same to the top as I've done to the bottom. So these two are not equivalent. And you can see that here. 2/5 is way smaller than 9/10. 9/10 is much closer to 1. So we can't put an equal sign between these two. They're not equal. They don't have the same value. This is 0.4. This is 0.9. So we need to use an inequality sign like this. So remember, crocodile eats the bigger number. So this says 2/5 is less than 9/10. Points to the left because as we go to the left on any number line, the numbers are getting smaller. As we go to the right, numbers are getting larger. 2/5 is obviously much smaller than 9/10. So that's one use of equivalent fractions. They can help us determine whether or not two fractions are equal. Another use is simplifying. So you've been asked to simplify fractions many times, and any answer you give in the test when it's a fraction needs to be simplified. In fact, when you're simplifying fractions, you're finding an equivalent fraction. You're finding a fraction that has the same value, but it's written a different way. It's written with lower numerator and denominator. It's written with lower numbers. So let's look at the number 9 over 99. I'm going to simplify that. What I'm going to do is I'm going to find a fraction, something over something, that has the same value as this, but this number's lower than 9, this number's lower than 99. So how do we do that? What we do is we divide top and bottom by the highest common factor. So the highest common factor of 9 and 99. I'm saying what is the highest number that goes into 9 but also 99? Turns out that number's 9. 9 goes into 9. 9 goes into 99. So to simplify it, I'm going to divide the top by 9 because I chose 9 because it's the highest common factor of these two numbers. But if I divide the top by 9, I must do the same to the bottom for them to be equivalent fractions. So what you do to the top, you must do to the bottom. 9 divided by 9 is 1. 99 divided by 9 is 11. So 1 over 11 and 9 over 99 are equivalent. They have the same value. They're both equal to 0.909090 recurring. They would occupy the same position on the number line, but this one is said to be simpler because it has a lower numerator. It also has a lower denominator. So let's simplify 24 over 40. So same idea. We have to find the highest common factor of 24 and 40. The highest number that goes into this number and also this one. So that number is 8. 8 is the highest common factor of these two. Highest number that goes into 24 also goes into 40. So I'm going to divide the top by 8. If I divide the top by 8, I need to divide the bottom by 8. What you do to the top, you must do to the bottom. So 24 divided by 8 is 3. 40 divided by 8 is 5. 3 over 5 and 24 over 40 are both equal to 0.6. They have the same value. They're a little more than a half, a little less than 2/3. But they are equal as fractions. They have the same value. They occupy the same position on the number line, but this version of the fraction is said to be simpler because it has a lower numerator, 3 less than 24, and a lower denominator, 5 is obviously less than 40. All right, let's look now at operations with fractions. So we're going to start by looking at adding and subtracting, and people find this difficult. The reason adding and subtracting difficult is because when you have a fraction, this line essentially means divide. So this is like 1 divide 44, this is 3 divide 44. See, dividing goes really well with multiplication, but it's not as compatible with addition or subtraction. What's difficult about this is that you can only add or subtract fractions when their denominators are equal, when you have the same number on the bottom. And when the numbers on the bottom are the same, you only add or subtract the numerators. You don't do anything to the denominators. So here, both fractions have the same denominator, so I can add them. So when I'm adding fractions, I only add the tops. 1 plus 3 is 4. and then I leave the denominator the same. I don't go 44 plus 44, I just leave it. Now, when you get an answer like this, you need to ask yourself, can I simplify? That's asking, does the top number and the bottom number have a common factor? Now, 4 and 44 have a common factor of 4, so I'm going to divide the top by 4. 4 divided by 4 is 1. I'm going to divide the bottom by 4. 44 divided by 4 is 11. So my final answer is 1 over 11. This was the right answer, but not simplified. So if I don't want to lose a mark in the test, I need to simplify. So that's all well and good when the denominators are the same, but what about here where they have a different denominator? So what we have to do is make their denominators equal. We need to find the lowest common multiple, that's what LCM stands for, of the denominators. I need to find the lowest common multiple of 15 and 6. So that's saying, what is the lowest number divisible by 15 but also divisible by 6? So 15 is not divisible by 6, so let's go to the next multiple of 15, 30. Well, 30 is a multiple of 15, but it is also a multiple of 6. So the lowest common multiple is 30. I need to make this number have a denominator 30. I need to find an equivalent fraction of 8 over 15 that has a denominator of 30. So to go from 15 to 30, I times by 2. So remember, for equivalent fractions, because we have that equal sign there, what I do to the bottom, I must also do to the top. So 8 over 15, I'm going to times 8 by 2 is 16 over 30. Similarly, for 1 over 6, I need to find an equivalent fraction with denominator 30. The reason I chose to make it have denominator 30, because it's the lowest common multiple of 15 and 6. So to go from 6 to 30, I've times by 5. So then I need to times the top by 5. So 1 over 6 is equivalent to 5 over 30. Now I've found two equivalent fractions with the same denominator. So 8 over 15 minus 1 over 6, 8 over 15 is 16 over 30. 1 over 6 is 5 over 30. Now that they have the same denominator, I can add or subtract. And I just add or subtract the top. So here I just go 16 minus 5 is 11, and I keep the same denominator. So 11 over 30 is my final answer, and I'm done. Let's move on to multiplying and dividing. So multiplying and dividing fractions is generally easier. Multiplying is really easy. You just multiply the tops and multiply the bottoms. So if I have 2 over 3 times 5 over 8, all I do is multiply the top numbers, the numerators, 2 times 5, and multiply the bottom 3 times 8. So here I've got an answer 10 over 24, but whenever I get an answer as a fraction, I have to ask myself, can I simplify? So I'm asking, do these two numbers have a common factor? Well, actually they do. They have a common factor of 2 because they're both even. So to simplify, I'm going to divide 10 by 2, and I'm going to divide 12 by 2. I divided top and bottom by 2 because it's the highest common factor of numerator denominator. So remember, of means multiply. So if you have 5/8 of 40, that's the same as 5 over 8 times 40. Now 40 is just the same as 40 over 1. You can write a whole number as a fraction by just writing it with denominator 1. So to find 5/8 of 40, I need to do 5/8 times 40 over 1. Now, when you have big numbers to multiply, sometimes you need to cancel to help with the calculation. So instead of doing 5 times 40, then dividing by 8, which is a bit hard, I can cancel. I can cancel anything on the top with anything on the bottom as long as they have common factors. So 8 and 40 have a common factor. I can't cancel 5 and 40 because these two numbers are both on top. I have to cancel something on the bottom with something on the top. So 8 and 40 have common factor I can cancel. So I can divide 8 by 8 to get 1, and I can divide 40 by 8 to get 5. So it's okay to divide the bottom by 8 as long as I do the same to something on top. So now it's so much easier. Rather than doing 5 times 40 and then dividing by 8, I can just do 5 times 5, which is 25. And on the bottom, I just have 1 times 1, which is 1. Of course, for 25 over 1, we don't need to write the over 1. 25 over 1 is just 25. So 5/8 of 40 is 25. Let's look at this one here. So a lot of people would look at 4 divided by a quarter and they'd say, oh, cool, it's just 1. It's not. 4 times a quarter is 1, but 4 divided by a quarter is actually 16. How did I get that answer? Well, when you're dividing fractions, you flip the second one and make it a multiplication. So what I'm going to do here is I'm going to keep the 4 and I'm going to flip the second fraction. So it goes from 1 over 4 to 4 over 1. So I flip the second fraction and make it a times. So remember, 4 is the same as 4 over 1. So I can write it like this. Now this is easy as. It's just 4 times 4, which is 16. And 1 times 1, which is 1. But of course, I don't need to write the over 1. 16 over 1 is 16. Because this is saying how many times does a quarter go into 4? A quarter goes into 1 4 times. So it goes into 2 8 times, 3 12 times, and it goes into 4 16 times. Let's look at this last example here. So fraction divided by a fraction. You always leave the first fraction the same. So that's what I'm going to do here. And then I'm going to flip the second fraction and make it a times. So 9 times 28 and 14 times 27, they're big calculations. They take me a while. I don't want to have to do them in a test. So what I'm going to do is cancel. You can cancel when you're multiplying. You can cancel anything on the bottom with anything on the top as long as they have a common factor. So 9 and 27 have a common factor, so I can cancel. 9 divided by 9 is 1. 27 divided by 9 is 3. So 14 and 28 have a common factor of 14. 14 divided by itself is 1. 28 divided by 14 is 2. So it's okay to divide by 14 on the bottom because I also divided by 14 on the top. What you do to the bottom, you must do to the top. Now, can you see this is way easier? It's so much easier doing 1 times 2 than doing 9 times 28. That's why cancelling helps. It makes the numbers smaller. On the top, I just have 1 times 2, which is 2. On the bottom, 1 times 3, which is 3. Now, this answer 2 over 3 can't simplify because 2 and 3 don't have any common factors other than 1. My final answer is 2/3, and I'm done. Let's look now at mixed numbers. So mixed numbers can be tricky. When you have to multiply, divide, or subtract mixed numbers, what you do is first convert to improper fractions. So remember, an improper fraction is just one that has a larger number on top than on the bottom. So this is how you convert to improper fractions. You take the whole number part, multiply it by the denominator, and add the numerator. So 2 times 6 is 12 plus 5 is 17. Now you always keep the same denominator. So the denominator of the fraction was 6, it's still 6. Do the same here. We go 1 times 12 is 12, plus 5 is 17. So 17 is the top, but here the denominator was 12. I keep the same denominator. So now that I've converted this number to its improper fraction, this number to an improper fraction, it's just a division like on the previous slide. So I'm going to keep the same first fraction. I'm going to flip the second fraction and make it a times. But you know what? I don't want to do 17 times 12. That will take too long in a test. So I'm going to look to cancel. 17 on the top and the bottom, I can cancel. I can divide the top by 17 if I divide the bottom by 17. And similarly, 6 goes into itself once and it goes into 12 twice. So what I'm left with is just 2 on top, 1 on the bottom. Of course, I don't need to write the 1 on the bottom. The answer is just 2. So that was made a lot easier by converting to improper fractions and then cancelling. So let's look at this subtraction here. So I'm going to convert this to an improper fraction. 3 times 5 is 15 plus 1 is 16. And I keep the same denominator. 3 and 1/5 and 16 over 5 are equal. They are both equal to 3.2. They would occupy the same position on the number line. That's why I can convert this to this. So 2 and 9/10. So 2 times 10 is 20 plus 9 is 29. So 2 and 9/10, that gives me 29 over 10. So now I'm just going to subtract these the way I did on a previous slide. Remember, before I subtract, I need to have the same denominator. I don't have that here. So what I need to do is I need to make these have the same denominator first. So the lowest common multiple of 5 and 10 is 10. See, if I times this denominator by 2, its denominator will be 10. But if I times the bottom by 2, I have to times the top by 2. What you do to the bottom, you must do to the top. So 16 times 2 is 32, 5 times 2 is 10. So I'm just left with 32 over 10 minus 29 over 10. So when you're subtracting fractions with the same denominator, you just subtract the top, 32 minus 29, and we keep the same denominator. My final answer, 3 over 10. So you can use the process of converting mixed numbers to improper fractions when you're adding. But when you're adding, you can do it a bit quicker. You can just go, for these two numbers here, you can just go 4 plus 3. So do the whole numbers first. 4 plus 3 is 7. And then add the fractions separately. So to add 5, 6, and 7 over 8, the lowest common multiple of 6 and 8 is 24. So if I times top and bottom by 4, and I times top and bottom by 3, I will have equivalent fractions with the same denominator. So 5 over 6 becomes 20 over 24, and 7 over 8 is 21 over 24. So now I have two fractions with the same denominator. I just add their numerators, 20 and 21. So I'm going to leave the 7 alone again. 20 plus 21 is 41 over 24. Okay, but I can't have 7 and 41 over 24. You can't have a whole number and an improper fraction. So I'm going to convert this to a mixed number. I'm going to go the other way. So the way you go from an improper fraction to a mixed number is dividing. Remember I said earlier that this fraction line here means divide. So to convert 41 over 24 to a mixed number, how many times does 24 go into 41? It goes once, remainder 17. So 41 over 24 is the same as 1 and 17 over 24. So my final answer, 7 plus 1 is 8, and 17 over 24. Okay, they are long calculations with mixed numbers. They are hard. Just make sure you practice them. All right, final thing we need to do is look at a worded problem involving fractions. So a worded problem is just where I don't give you the actual sum, like what you have to add or multiply. I just give you a bunch of words. But of course, all of the worded problems on fractions, you'll either be adding, subtracting, multiplying, or dividing fractions. So let's look at this one. James works for 2¼ hours Friday, 1½ hours Saturday, 3 and 5, 6 hours Sunday. How many hours does he work over the 3 days? Well, that's just asking us to add this, this, and this. Doesn't matter the guy's name's James. Doesn't matter that it's work we're talking about. We're just being asked to add 3 fractions. So this is just like what we did on the previous slide. So to add these up, I can go 2 plus 1 plus 3 is 6. And I'm going to add 1/4, 1/2, and 5/6. I'm doing the whole numbers separately to the fractions. So on the next one, the lowest common multiple of 4, 2, and 6 is 12. I'm going to make these 3 fractions have denominator 12. So 1/4 is 3 over 12, because if I times 4 by 3 to get 12, I need to times the top by 3. 1/2 is the same as 6 over 12, and 5/6 is 10 over 12. So now when I add fractions with the same denominator, I just add the numerator. So 3 plus 6 plus 10 is 19. This is 6 plus 19 over 12. So I'm going to convert this to a mixed number. So 19 over 12. How many times does 12 go into 19? Once, remainder 7. So it's 6 plus this is 1 and 7/12. So he has worked for 6 plus 1 is 7 hours and 7/12 of an hour. 7 and 7/12 hours. So if he's paid $10 per hour, how much will he be paid if he works this number of hours in 6 weeks? So each week he is going to earn 7 and 7/12 times 10. So when you're timesing mixed numbers, remember, convert them to improper fractions. So improper fractions, 7 times 12 is 84 plus 7 is 91. So it's 91 over 12 times 10. 10 is 10 over 1. So we can cancel here because 2 goes into 12 6 times and it goes into 10 5 times. So here we end up with 455 over 6. This means 455 divided by 6. So you can use long division for that if you want. The answer we get is 77.5. He earns $77.50 every week. So how much will he get over 6 weeks? Well, he will just get 455 over 6 times 6 weeks. So then I can cancel the 2 6s because I can divide bottom by 6 if I divide the top by 6. And I'm just left with 455 over 1, which is just 455. So he earns $455 in total. So what I did was times by 10, and I figured out this is how much money he gets in 1 week just by doing some multiplication there. So in 6 weeks, I just have to times that amount by 6. But when timesing by 6, I can just cancel these 2 fractions here. And cancelling the 6 leaves me with a 1 on the top and the bottom. 455 times 1 is 455. 1 times 1 is 1. I'm just left with $455. All right, sorry for the long video, but keep your head up. You're a superstar, and I know you're going to ace the test. Please let me know if you need any help. This has been the luckiest maths teacher in the world. Have a great day.